Hi everybody, Physics Ninja here. Today we've got 3 more geometry proofs allow you to practice some problems. In the first problem we have a pyramid with a square base that's kind of been unfolded. The angle of the isosceles triangle at the top is 20 degrees. I'm asking you, how do you find what the angle is that I've denoted by the letter B? What is that angle? In the second problem, we have a more complicated problem. In this case, again, we have a pyramid that's been unfolded and it makes this star formation here. I'm giving you the angle of each, that acute angle in the isosceles triangle of the star. And again, I'm asking you to find a more general equation for the angle B in this case. And then the last problem what we have is just a circle. We got a couple isosceles triangles inscribed in that circle. Again, if I'm telling you that the angle BAC is equal to 34 degrees, how would you solve, or how would you find what the angle B is in this case? So let's go ahead and show you how you solve these problems. All right, here's problem 1. We have a diagram of a square pyramid. The base is square, rather not the pyramid. The triangles are isosceles. And the angle, the acute angle over here is 20 degrees. All right, how do you calculate the size of this angle B right here? All right, so probably a lot of different ways to do this one. I'll show you the way I did it. So I started here at this square, at the corner here of the square base, and I just extended these lines a little bit. So let's do that, and I'll extend this one. All right, now we're going to also split this isosceles triangle right down the middle, because if that full angle is 20 degrees, if I can cut it right in half, that means that each one of these has to be 10 degrees, right? Each angle, and they're all the same. So each one is 10 degrees on this side and that side to give us 20 when you add them up. All right, now an important rule right here is this. You see this shape here? We have 2 parallel lines. We have 2 parallel lines, and if I know that the angle is 10 in that angle, I have to know that this angle here must also be 10 degrees. Now you can argue that since all these isosceles triangles are the same, that means that this here must also be 10 degrees. Boy, we've got 10 degrees all over the place here. So at the end, all you need to do is just sum them all up, right? Because the angle B is made up of 2 of these smaller 10-degree angles with an additional 90 degrees in between. So at the end, all you have to do is simply say that B is going to be equal to 10 plus 90 degrees plus 10 degrees. Now at the end, this problem is pretty straightforward actually. 110 degrees is what you get. All right, not too complicated. A little warm-up problem just to get us started. Okay, so to make things a little bit easier, what I've done here is I'm going to zoom into this picture. So over here, I've just kind of zoomed in because we really want to kind of look at this overall section. It's the same whether I look at the top case or any of the other ones, just because of the symmetry of this star shape. Okay, so what we've done here, this is the angle B that I'm looking for. What I'm going to do is I'm just going to extend some of these lines, and there's nothing that's going to stop me. It's just going to help me visualize things a little bit better. Now you can see some shapes that keep popping up here. Here's an isosceles triangle. So let me denote this angle here as X. So this here has to be X. And if it's a triangle, this here must also be X. Where else can I place this angle X? I can place it right here. That's going to help me in just a little bit. Now the other angle which I really want to know is if I can know this angle, that's also going to help me. I'm going to denote this angle by the letter C. Now, one thing to be careful of, C is not equal to B, so we have to be a little bit careful. Okay, you definitely saw that for the previous problem. In the previously problem, we had a square base, so C was 90 degrees, and B was equal to 110, so they definitely were not the same. All right, let's go ahead and write down some relationships here that are going to help us. First of all, let's focus on this isosceles triangle. I know that if I add all of the angles inside the isosceles triangle, I better have 180. So 2x plus the angle 20 must be equal to 180. I'm just going to call this equation 1. I'm not going to simplify it for now. We'll just leave it like this. So what else do we have? Well, if I add up all of the angles here, right? If I add them all up, right? So let's write down an expression for that. I have to have 360 degrees. So in this case, I would have b plus, there's two x values. There's one here and one here, 2x. Well, that's good because that helps me over here. And what else? Plus the angle c. And if I add all of those up, I have 360 degrees. So this is, I'm going to call this equation 2. Now, one thing we could do is we can use equation 1 and substitute it into equation 2. And let's eliminate 2x. All right, so this is going to look like this. B plus, instead of 2x, I'm going to replace it by 180 and minus 20. And I'm not going to simplify that just yet. I'll just leave it like that. Since my final answer has 20, it doesn't really bother me that it's going to stay like that. And that equals to 360. All right, we're actually almost done the problem here. So let's go ahead and simplify this a little bit. I have 180 on this side, and I have 360 on this side. So that means if I take away 180 on both sides, it's going to look like this. So at the end, what we have is b minus 20 plus the angle c has to be equal to 180. Okay, so this is where I am right now. Let's go ahead and box that up. Now there's one more thing I need to do in order to get to my final answer. Notice that my final answer doesn't have this angle c in there, so I need to somehow eliminate or find a value for this. So this is the angle c, and it's the angle inside this shape, right? This is the angle c, and actually I can add them up. If I would add them all up here, I would actually get n times c, right? If there's a way to find out the angle inside this polygon, I'd be off to the races. Because if I was able to add all of these, I would have simply n times the angle c. All right, well, luckily there is a theorem that allows me to do that, okay? There's a theorem that says that if you add up all of the angles inside an n-shaped polygon, that the value is n minus 2 multiplied by 180. And I'm sure there's tons of videos on this. In this case, n equals to 5. But if I now want to get an expression for the angle c, I just have to get rid of it on this side. So I'm just going to divide through. So at the end, I get n minus 2 multiplied by 180 degrees, and over n, this gives me one of those values for the angle c. So now what we can do is simply substitute that value c inside my expression over here inside the box. And let's go ahead and do that. I'll bring the 20 on the other side. So we're going to have 20 plus 180 and minus the angle c. So we have 20 plus 180 and minus the angle c. The angle c is right here, so it's n minus 2 multiplied by 180. All of this divided by the number of sides n. All right, now we have to do a little bit of algebra just to simplify this expression. You notice that the first term here I could divide by n. And here if I multiply through by the 180, actually it's going to end up canceling with this term. This is going to cancel with this term. So at the end, what you're left with here is that the angle b is going to be equal to 20. The negative signs here cancel out when I multiply that through. So I get plus, and 2 times 180 gives me 360. And I still have the n term here that's left over. So this problem is actually quite complicated, right? We use quite a few different concepts here. We use the sum of the angles for a isosceles triangle or any triangle summed to 180. We also use that if you add up all of the angles inside a circle, basically what we get is 360. And the last part is I use this theorem here, which says that if I have an n-shaped polygon, that if you sum up the angles inside this polygon, in this case all the angles are the same because the polygon is symmetric. So that's why I get 5 times the angle at one of the vertices. All right, anyway, hopefully you understand these steps and you're able to solve this problem. Here's the last problem, probably the easiest one. It says the acute angle appears 34 degrees. 34 degrees, mark that off. And now they say calculate the angle ACD. The angle ACD is the one denoted by this red line here, and then we're going to call that B or angle ACD. It doesn't really matter. So to start this problem off, what I'm going to do is I'm going to slice this right in half. Here's the center of the circle. Again, if I could just continue that line up here, and I can continue it down at the bottom. And let's denote this angle inside this larger isosceles triangle. So this angle over here is the angle ACB. So the angle ACB, this one we should be able to simply write out, because we know that this guy over here has to be 17 degrees, because I've simply cut this acute angle of 34. I've cut it in half by making a line like this. All right, so that means right away I should be able to write that if I add up all of the angles inside half of this isosceles triangle, I have to get equal to 180. But this angle down here is 90 degrees. So that means that the angle ACB plus 17 have to be equal to 90. So that means that ACB has to be 90 minus 17, which gives me 73 degrees. So that's pretty straightforward. And now the last one, well, all you have to do now is simply focus on what's going on over here. Okay. So what we have is we have a line that is going from C to A. And I've solved for what this angle is. That green angle that I've defined is 73 degrees. So if I add up the 73 plus the angle B, right, that makes a half circle. So both of those have to sum to 180 degrees. All right, because we have a half circle on this side. So the last step is B is just bring the 73 on the other side. And what you're left with is 107 degrees is the angle B. Okay, so pretty straightforward. If they give you any information about this triangle up here, you should be able to find what this angle outside is. Thanks for watching.